Good morning everyone. In this class we will learn about route stability criteria, which is very important for gate point of view, and for university examinations also it is very important. So before going to that, I will revise about this course. So this course is aircraft stability and control. I hope everyone remember that. So stability is nothing but a tendency of any system. So in stability we can classify it into three parts. One is stable, statically stable, and unstable, and neutrally stable. So past three units, so unit 1, 2, 3, and those are deals with the static stability of the aircraft, and upcoming unit 4 and 5 it deals with the dynamic stability of the system. So nothing but our system is the aircraft. So we can say like so generally if the system is, I hope by this time you completed our control theory course, first 2 units. So in those 2 units we will get some characteristic equation, that is nothing but, so by using transfer function how can you comment on stability of the system. For example, if the system is second order systems, by observing poles you can comment on the stability of the systems. If poles are negative, then you can say the system is stable. If any one pole is positive, then the system is unstable. So like that you can comment on stability of the system. So there are a lot of techniques to comment on stability of the system. That number one is route stability criteria, and root locus method, and border plot method, and Nettles plot method, Nicholas plots. So especially in route stability criteria, if you have any characteristic equation, by observing characteristic equation, or we will use one route array technique. That thing we will discuss later. So if it is higher order characteristic equation, for example, if the order of the characteristic equation is 6, then it is very difficult to find the roots of the systems. So in that case, mathematically we will use these techniques to find the stability of the system. So if it is second order systems or first order systems, by observing those roots we can comment. But if it is higher order terms, then it is very difficult to calculate roots of the that characteristic equation. So generally in aircrafts we will get fourth order systems. So that thing we will discuss in fourth and fifth units. So when you are dealing with fourth order systems, it is very difficult to calculate. It is very difficult to calculate like roots of the systems. So that's why we are using this route stability criteria.